Hi there guys, today what we're going to look at is finding the sum of an arithmetic series. So let's have a go at this. I want you to add those 5 numbers up very quickly for me. Hopefully you've paused the video to do that, and it shouldn't take you very long at all. You've done it in your head and you're now ready for the answer. Should have 15. Now that's the easy problem. But what would you do if I said I want you to add up the first 100 numbers? You'd probably blow out your cheeks and put your pen down and say, what's the point? And that wasn't the same for a very famous mathematician called Carl Gauss. He's a German mathematician, was around in the 1700s, and he is world famous for doing that exact problem, not at your age when you're watching this, but whilst he was at primary school. He found a way of adding up the first 100 numbers, or it might have even been 1,000 numbers, and he did it in a matter of minutes. So there's lots of different theories about how he did it, whether using like triangular numbers, but this is the theory that he then later wrote down, that we use today. So what he realised is if you find, so S for sum, okay, this will be easy, 1 add 2, add 3, add 4, add 5. Well, that's going to be exactly the same, isn't it, if you do it backwards. So if you write this backwards, so 5, add 4, add 3, add 2, add 1. And he noticed that something very special happens here. You get the same number if you add them together. So what he said is, well, 2 S's, if we add these together, would be 6 lots of how many numbers we have. So if we're after the first 5 numbers, you can see it's 1, 2, 3, 4, 5. That would be 6 lots of 5, and therefore 2S was equal to 30. And then S is equal to 15. So you can easily add these numbers up, but we've just found a way of doing an alternative way. And this actually will allow us to add up as many numbers as we want to very, very quickly. So to make that make a bit more sense, we're going to try and make it a bit more mathematical. So let's say this first one is A. Let's say we don't know what it is, so it's going to be A. And then we're going to plus the next number. So it's an arithmetic series, so there can be any difference we want. So it doesn't have to be consecutive numbers. It can be any number. But let's treat it as consecutive. So let's just say, well, it's A plus whatever the difference is. And then the next one's going to be A plus 2D, isn't it? And then we're going to keep going and going and going until you put a question on it. So like the 15th or the 20th or the 30th. But you should realise that using our nth term of arithmetic series, it's always going to be n plus n minus 1 d. For example, at first term, no d's. Second term, 1d. Third term, 2 d's. The nth term, n minus 1 d's. Okay, so let's say that's the sum. And that's going to be exactly the same if we do it backwards. So that's going to be a plus n minus 1d plus blah, 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 blah. Eventually, we'll get back down to this sort of level. So let me put brackets around there because it's looking a bit messy. We're going to have, let's put these ones in. So we're going to have a plus d. And then eventually, we're going to have a all on its own again. So using this theory, like if we add these up, we're going to get this value here. So if we add a, can get quite confusing. Let's put a. So we're adding the first and the last term of our sequence. So we're going to have 2 S's. It's going to be 2 A's plus n minus 1 d. Okay, so that's this bit here. But what we've also got to do now is think, well, here we had 5 numbers, so we had to times it by 5. We had 5 lots of this 6. So this 6 is now this as an expression for any sequence in the world. But we now need to times it by how many numbers we would have. And here we had n numbers. So what we need to do is times this all by an n. So 2s is equal to n brackets the first number plus the last number. So therefore s, we need to half it. So what we say is n divided by 2 is equal to 2a plus n minus 1 d. You can put square brackets if you prefer it, but you know, it doesn't really matter. So that is the formula that will find the sum of any arithmetic series. However, let's change colour again. If you know the first number and you know the last number, you don't actually... Oh, that's the worst S ever seen. Let's just do that again. There we go. If you know the first and the last number, if you think about what we did here, that was the first, and we added the last number. So this is the first, and this would have been my expression for the last number there. So that is just saying the first plus the last. So instead of doing that, if we know them, we could say this. So exactly the same here, but A, the first, plus the last number. So these are both technically the same thing, but here you can use this one if you don't know the last number, and here you can use this one if you do know the last number. And you can see that's a lot easier to use, this bottom one. Okay, so that's kind of a nice slow intro into how this all works. Hope that makes sense. Now you're going to watch the next video to make sure we can use it.